sheet metal design. Sheet metal design is the core capability of Solid Edge ST6 Foundation with support for the entire design through fabrication process. Presenting this webinar is Kevin Grayson, a Solid Edge solution consultant in the Siemens Group with more than 13 years of experience with Solid Edge. Kevin has also worked as a Solid Edge certified instructor and has trained hundreds of Solid Edge customers. Before we get going, here's an overview of what we do at Novedge. Novedge is one of the largest online design software stores. We offer a huge assortment of software solutions that cater to virtually every designer's need. Put us to the test and come visit our webpage at novedge.com. For more rewards and special, you should always check the Novedge blog. Keep up with the latest software updates and enjoy inspiring interviews. You can also get daily software news following us on Facebook, Google+, and Twitter. Coming up next week, the ultimate Revit Custom Material Marathon. Learn how to find, create, and manage your own custom material libraries in Autodesk Revit. Last but not least, today's presentation is free and is being recorded live. If you want to rewatch this or any webinar episode, you can find it on YouTube and Vimeo channel. Just search for Novedge. And now, without further ado, I'm going to pass the baton to Kevin and make him the presenter, so he can show us his screen and his fantastic presentation. Here to you, Kevin, and I'll talk to you at the end of the webinar. And please, if you feel like asking any question, input them in the question box, and we'll have a short Q&A at the end. Good luck, Kevin, and enjoy the webinar, everyone.
Great, thank you. So I just want to thank everybody for attending the webinar today. Whether you're watching live or on the replay, we're going to talk a little bit today about the superior sheet metal capabilities that you'll find inside of Solid Edge. One thing that you'll notice is we're going to go through and talk just a little bit about some of the industries that Solid Edge sheet metal can be found in, and we're going to also talk and show you within the product itself some of the applications that you'll find sheet metal in within different industries. What you're going to notice is we're going to utilize an actual data set from one of our customers. This is what you see here is from a company called Dixie Chopper, and they produce what's known as the fastest riding lawnmower. This is called the Iron Eagle. And as you'll notice here, we have a number of different components. This particular assembly is just shy of 1,200 unique parts. And as you can tell just by looking at it, I would say probably 60 to 70%, if not more, are comprised of sheet metal components. One of the nice tools that Solid Edge has to offer is the ability to very quickly find different types of components within the assembly. You'll notice here we have what we call a query, and what I can do is I can find, just by double-clicking, all of the different components that are made out of sheet metal material. So as you'll notice here, it highlights for us on the screen, and we can find those very easily. Now, the actual assembly itself is a replication here of what you see here on the screen, and I'll show you an actual image of that here. So as I go to the customer location, I'll show you an actual picture of this, and bear with me for 1 second. As I pull this up, here's an actual image of the model that we're going to be looking at today and doing some design work on. So if you look down here at the deck assembly, you'll see a sheet metal housing, and this is the part that we're going to be looking at today within the application of the webinar. As we come back here to Solid Edge, as we go back to the query and we highlight those sheet metal components, here in the webinar, this black color may not show up as well. So what I'm going to do very easily is change the display of those. So I'm going to change them to more of an aluminum display. And then also at the same time, I thought what would be nice would be to show only the sheet metal components in the context of the assembly. So as I spin the model around a little bit, and as we're showing just the sheet metal parts, you'll notice we have a different range of different types of sheet metal parts. We have very thin, flat plates, which may have some etching. We also have some components that are bent to form the shape of the final component. So we're going to be working with, as I mentioned, designing a component within this assembly and just show you some of these very capable sheet metal applications. What I'm going to do is I'm also going to change the display to what we're going to focus on in the assembly. We're going to look at the deck assembly, which shows the different components for our belt and pulley system. These run the blades that cut the grass underneath of the blade housing that you see here. And again, we're going to show you just some of the modeling capabilities, modeling the sheet metal part from scratch within the context of the assembly. And you can get an idea here of some of the tools that are going to be available to you inside of Solid Edge. We're going to be doing this design, as I mentioned, in the context of the assembly. This is going to allow us to reference existing parts so that as I'm doing the design work, it's going to allow me to make sure that not only the form of the part, the shape of it is not going to interfere with other parts, but again, it allows me to do that without having to bring that part in later and make sure that there's no interferences. I can do that right from the start. So what we're going to do is we're going to start off just by drawing some simple geometry. You'll notice that with a simple right mouse button click, I get access to some commonly used tools. This will save me some mouse travel with selecting commands that I might want to operate. So again, just by simply dragging my cursor on the screen, I can type in some values to construct a rectangle on screen, and it will display that for me here as we're designing this cover that's going to protect our belts and our pulley system. So creating 2D geometry, very easy to do. Just by selecting the rectangle itself, I can turn that 2D rectangle into a 3D object very quickly. What you'll notice, since we are working with sheet metal, is we may want to specify material characteristics. And just by simply double-clicking over here on the left-hand side of my panel, I can get access to material tables and material characteristics from a library. So for example, you'll see we have an extensive list of steels, aluminums, and other types of materials that I may want to apply to the part that I'm constructing. So for example, if I were to choose steel or maybe 6061 T6 aluminum, all my material characteristics are there. These can be modified, edited to the capabilities or the standards of the company that's using this. You'll also notice, for example, specifically with sheet metal, I can specify gauge properties. And I can specify, for example, what gauge material I want to utilize. And with that, we have material thicknesses, bend radius information. We can also specify a specific bend equation and neutral factors that are going to allow for how the material is going to be bent with the tooling that my particular company utilizes. So as I apply that to the model that I'm working with, it'll notice it changes the display to the material that I've specified. The other thing that you'll notice is the dimensions that I keyed in when I was constructing the rectangle, they automatically will attach themselves to my solid model, and I can utilize those downstream to make edits later on. Now we have a nice flat tab here. I may want to also go through and add some additional material for my cover. And just by simply selecting those three edges, you'll notice that I can automatically pull multiple flanges to construct kind of a box shape to cover those components. And you'll see that I've got 3 walls to this box. If I spin this around to look at the other side, you can see that I've left the other side open just to give the operator access, maybe for some maintenance purposes. If you do any design work in sheet metal, we looked at some of the characteristics of the material that we defined with bend radius information, bend allowances or bend deductions that are you have to take into consideration. And if you've ever used any other CAD systems to design sheet metal components, you find yourself that you have to be constantly aware of whether you're designing something to fit over top of something or whether you're designing this sheet metal part to fit inside of something. And the dimensions that you place on your part have to account for those bend radiuses and your material thickness. And what I want to show you is right now the dimension that I'm highlighting, it's referencing the outside shape. So I can modify that, and you'll notice that my part automatically updates as I change that dimension. What's nice about Solid Edge is we give you the flexibility. If you don't want to define the size of your part with the outside, you can add dimensions at any time, maybe, for example, to the inside of the part. And if I want to drive the size by keying in a value that changes the inside components or the inside faces of my part, I can do that, and you'll notice that the outside dimensions automatically change for me. That operation in some of the other CAD systems out there on the market is not easily done. I'm going to go ahead and turn off those dimensions for now. We'll come back to some of those in a little bit. I want to make some additional modifications to my sheet metal part. And you'll notice it's very obvious here. We've got some interferences with our spring and maybe our pulley and our belt. And I may want to just add some additional material to the sheet metal. So very quickly, I'm just going to draw just a very simple line on the side of my box. And utilizing a nice solid edge sheet metal feature called a jog, I can very quickly add a bend, or I'm sorry, two bends and a flange simultaneously, and just give myself some additional material to work with. Now, by doing that, I still haven't eliminated all the interference, but you'll see here in just a second, I'm going to do that very quickly. Now, the operation I'm about to do in Solid Edge is either impossible in some of our competing products, or it would take quite a number of operations. But what you'll notice here is I can take just the side face of my sheet metal part, and just by simply taking this editing tool and snapping it to the edge of my part, what I can do is very easily rotate that face to an angle to where it's not going to interfere with those other parts. So I can type that value in, and notice just by simply rotating that edge out, it modifies the overall shape of my sheet metal part and eliminates that interference with our belt, our pulley, and our spring. So very easy to make changes to your sheet metal geometry here inside of Solid Edge. I have just a little bit of interference over here as well, so I may want to go through and we look at this from a top view. I just may want to push that in just a little bit and remove that interference, maybe push that in 10 millimeters so that it's not interfering with our other part. So again, you just simply click on the face or the edge of the part. You can very quickly drag it to a new position and make those changes. I'm going to spin this back over to the other side. We have a nice general shape of our sheet metal part, but we need to make some additional adjustments to it to complete our design. As I spin this around, you'll notice we have a little gap here. We may want to close up that gap. And again, as I did before, I can very quickly grab an edge and pull a flange off of that edge. Now, I want this face here to match the same angle as this back face, but I don't know what that angle is. And that's okay, because inside of Solid Edge we have these different tools that allow us to relate different faces to be the same angle or to coincide with each other. And we have this option here called Coplanar. And very similar to what you may do in a traditional CAD system where you're applying these different constraints inside of a sketch, we can do that directly to the 3D model. So just by simply clicking on those two faces, it automatically pushes that angle out to match the same so that we get a nice aesthetically pleasing part. Now also very intuitively, I can come in and place a dimension between those two faces, and if I want that to be a certain value, let's say maybe 1 millimeter, I just simply put a dimension on it, change it to the value that I want, and it'll update the model for me automatically. Now, currently our sheet metal cover is just sitting on top of the deck assembly, and we actually need to mount it. So again, we have some existing hole locations in the deck. We want to go ahead and utilize those. So once again, I can add multiple flanges at the same time just by simply clicking on those two edges, and we'll extend those out. What you'll notice here as I do that, on the left-hand side, we look okay. We have enough material that we can mount with the existing bolts, but over here on the right-hand side, we have a little bit of an issue. Now, I could go ahead and just pull these flanges out and make them to where they are the proper width to where we can mount this down. But we may have some other applications. Maybe there are some maybe some strength issues. Maybe we want to make this box maybe just a little bit stronger from outside forces and maybe change the geometry a little bit. So the first thing that I'm going to do is, again, you'll notice that we can place dimensions directly on the 3D part itself. I don't have to do that with the sketch first. If I want to place a dimension for the length of that flange, I can do that very easily. Bear with me, I accidentally hit my little rotation device. But let's come back here. Let's say we want that to be 35 millimeters, and we can go ahead and apply that dimension to it. And what we may want to do is, instead of this face of our sheet metal part being a vertical face, maybe we want to put a little bit of angle to that to strengthen this area of the part. And what you'll notice here is, as I click on this face, again, I can utilize that same editing tool we looked at before, and I can very quickly utilize it to rotate this face out to some degree. And notice what all's happening. You'll notice that the back face of my part is also adjusting as I rotate that editing tool and rotate that face out. So not only does it rotate the face that I selected, but it also changes the shape of this back flange here to keep it matched and make it look nice. Now I'm going to hide all the other components for a second, and let's just focus right now on my sheet metal part itself. You'll notice that I don't have any mounting hole locations to where the existing bolts and nuts here that exist inside my assembly can come up through. But we have some nice tools inside of Solid Edge to add those very quickly. What I'm going to do is I'm going to utilize this tool here called Subtract, and all I have to do is say subtract from my part the locations for these two bolts, and I just select the bolts, and that quickly I now have my new holes. And if I want to see specific information about those holes, I can do that very easily. And you can see that it tells me that this is a simple hole, and if I wanted to come in and make any modifications to what type of hole it is, or maybe the size of it, maybe give it a little bit of clearance there, I can change those values and have it modify that for me automatically. But I didn't have to go in there and manually place those holes. I just told it to utilize the existing bolt location, and it puts those in there automatically for me. Just a couple of other things here. I may want to just do a couple of other aesthetic operations to this. Again, I may want to make this face on the flange match the same angle as the other two, so I can very quickly just change that and add a little cut there to match those two faces. The other thing I want to talk about in terms of dimensioning my part is I can specify different dimensioning controls. And what do I mean by that? Well, what you'll notice here is as I place a dimension on this edge here, what Solid Edge gives me the ability to do is specify specifically how I want to change that dimension. And let me rotate the model around before I do that so we can see that a little bit better on this side. So as I place that dimension, inside of Solid Edge, we give you the ability to specify, do I want this top face to move, or do I want this bottom face to move to where that dimension is located? So you'll notice with the arrow pointing to the left, if I change the dimension, it modifies the top face for me, and I may want to leave everything else where it is. Or I may say, no, I want to leave that face where it is, and I want to go ahead and push the bottom face. So as I go through and change the direction, I have the control as the designer to specify exactly which one I want to move. The other thing that we have the ability to do here is if I want to change multiple things, multiple elements of my part via that dimension, is I can select them first and do it with a dimensional change. So maybe I want this back flange to move with this top face, and again I can just go through, type in the specific value that I want those to be, maybe in this case 40 millimeters, and have those move simultaneously. Just a couple of other operations here. You'll notice that we have some slight interference with our shaft that's holding the pulley with the top face of our part. I may want to go through and add some other features that's going to eliminate that interference. Before I do that, though, I may want to maybe add a little bit more clearance for maintenance, maybe just put a little bit more area here for operators to get in there and maybe change the belt, remove the belt from the pulley, or do some other operations. So very similar to what I did before, I may want to snap this over to the right-hand side and just rotate this out some angle. So maybe we'll rotate that out 25 degrees and give ourselves a little bit more clearance. And then the other thing that I want to just talk a little bit about is just creating 2D geometry, again, to help in creating some of these different sheet metal features. What I'm going to do is just draw a very simple circle on this top face, and then maybe also include some other elements off of some other components. Maybe I want to include the location of our belt in those two locations. And then just utilizing just very basic sketch definitions, we'll make that circle tangent to those two edges, and then just make sure they're all connected together. So we'll do that very quickly to get the shape that we're looking for. And I'll just go ahead and trim away any elements that I don't need. So I've got this shape right here on this top face, and what I may want to do to eliminate that interference, I may want to utilize some deformation features. And you'll notice we carry a number of deformation features inside of Solid Edge, whether it's a dimple to dimple the material. And you'll notice some nice training operations that are available. It gives you a nice video of how to complete this operation if you're a new user to Solid Edge. But I just may want to dimple that element there, and I can specify how deep that dimple is. Maybe in this case I want it to be 5 millimeters. And we've taken that shape very quickly and added that deformation feature. Again, as we hide the background components, maybe just a couple of other operations. With this being sheet metal and being very thin, I might want to eliminate some of these sharp corners. I just simply window around those corners with what we call a break corner option, and just break that with a round. And very quickly I've eliminated any hazards to these sharp corners here. Now obviously with this being sheet metal, it's nice to have the formed sheet metal part, but for manufacturing purposes we need to go ahead and add a flat pattern so that we know exactly what size the sheet of sheet metal needs to be before we bend it up. So in Solid Edge we have this nice flat pattern tool. All we simply have to do is specify which face is going to be up, and then it flattens it for us. The other nice thing that we will do is we will give you the cut size, so you know exactly how large your sheet needs to be in order to produce this part. So we can toggle back and forth between our flat pattern as well as our formed part very easily. And as we look at this in the context of the assembly, we've generated this nice sheet metal part from scratch around these existing components, and our design is now complete. As far as documenting this, we may want to go through and place this on a 2D drawing. So what I can do very quickly is just say, let's produce a drawing of our model. And what they'll allow us to do is, if we will come in, as I open up this blank sheet metal template, if I want to come in and add some different views to this, I can. And what I'm going to do is I'm going to come back out and let's go ahead and save our sheet metal component. We'll save it to our library here. And then what I can do is just place this inside of a drawing. So what we'll show you here is inside of the drawing itself, we can come in and update the views, and when I place that part model inside of the drawing, it'll go through and allow us to make any types of adjustments that we need in generating the drawing. So this is what we call a Quicksheet template. The Quicksheet template allows us to place different views. So in this case I have a nice rendered isometric view, and then I also wanted to place a nice flat pattern view on the sheet as well. So what's nice about this is I can generate a bin table. Allows me to specify the bin locations and which direction they are, as well as some other information. So in this example, I may want to call out the bin number as well as the bin direction, and then maybe just add a simple title to this table. We'll call this pulley cover. And then as it automatically generates the table for me, it labels all the bins, tells me which direction they are, and then I can reference my table just to get other information. What's the sequence of bins? what the radius is, and then again what angle those need to be bent. So very quickly we can document this from a manufacturing perspective. I'm going to flip back over to some other applications that we're going to go to and discuss. And let's go back to the assembly for just a second. And we'll look at some other areas of this assembly. So as I rotate out here to the front of our deck assembly, we also have another mechanism here that allows for the grass to shoot out after it gets cut. And we'll go ahead and show you some of the tools that are available here. And we'll just kind of simulate how this particular mechanism works. So you'll notice here as I grab the handle, basically just lifts up on the sheet metal arm, and the operator, as he's sitting in the chair, would pull this up or down to allow the grass to come in or out, or to extract itself from underneath the deck. Now, as we look at some of these components, I want to talk about some other applications Solid Edge has from what we call a multi-CAD perspective. So let's go into how this assembly was constructed. What you'll notice here is we have a sheet metal component here. This particular part was designed from scratch in Solid Edge, very similar to how we designed the pulley cover. But in a lot of cases, you may be working with suppliers, or you may be working with customers who are working with other CAD systems, and you need to collaborate or maybe utilize some of their data to help you in finishing your design. So what I want to do is talk a little bit about how we can handle this from a multi-CAD perspective. And as I go to File Open, you'll notice the number of different file types that Solid Edge is able to open up directly. So if you look at the top of the list, we have native Solid Edge documents, our parts or our sheet metal components or our assemblies. As we look down the list, we can also open up many of the other CAD applications that are out there on the market today, from 2D as well as other 3D applications. What I'm going to do is I'm going to go into another CAD application, and we're going to open up one of its components. So as I select that application, I just tell Solid Edge to open it up directly, and I can just specify what standard I use, whether it's metric or English, and open that particular file up inside of Solid Edge. Now, if you've ever worked with CAD systems and brought in data from those other systems, you'll notice that the history or the features that were utilized to design that part, they don't come across automatically. So this part will come in as what we call an unparameterized part, or what the layman's terms might be called a dumb solid. There are no features to it. But Solid Edge has a lot of applications that allow us to add intelligence to this model as though it were designed natively inside of Solid Edge. So one of the tools that's available is I can optimize this part. And what that means is if there are any errors in the part, it'll go through and look at the part and fix any errors that might be there. So for example, if a hole should be a circle or a cylinder versus an ellipse, it'll go through and convert the ellipse or the B-spline to analytic geometry and just make it easier to work with and easier to edit. So we can analyze any data that's been imported in and make it much more user-friendly to work with. The other thing that you'll notice is I can very easily modify this part. If I came through and changed this part, I can stretch it. I can make changes to it very easily, or if I wanted to go through and place dimensions on this part and parameterize it myself, I can come through here and specify that I want to make modifications to the length of this part and just go through and do that right here on the fly without having all of the history that part was constructed with in its native CAD system. We'll go ahead and we'll save this, but before I do that, the other thing that I want to talk about is I can actually convert this imported part with very common and very intelligent sheet metal specific features. So you'll notice over here, if we look on the left, this is just labeled as what we call a part copy, and everything is listed as just one item. Well, what I have the ability to do here inside of Solid Edge is we have this option here called Transform. And what that allows me to do is transform this to a recognizable sheet metal feature. So now instead of one item here as a part copy, I now have a tab and two different flanges here that I can now edit very easily and have those labeled correctly. So we'll go ahead and we'll save this part out, and we'll just leave it as the name that it was brought in as. And I want to utilize this inside of my particular assembly. So I just simply come over here to our library, and I find that component, and I just simply drag it in. And what we'll do is we'll start to place this inside of the assembly. The first thing I might want to do is just place this face against this face over here. I want to do that with a 1mm offset. And let's go through and we'll go ahead and assemble these components together. All right, the second thing we might want to do is go through and align the holes. So we'll place those in there as well. And then maybe line up this top face here, and let's put it at the same angle as the face over here on the side. So again, you'll notice that we've got the nice offset, we've got enough clearance in there so that these two parts aren't rubbing together, but as we look a little bit closer, we'll notice that the part that we want to utilize is a little bit too long. So we want to go ahead and make quick changes to this to make this fit inside of our design. And one way that we can do that is by modifying it right here at the assembly level. Before I modify it, though, I want to find out what is the distance in between these components. So Solid Edge has some nice 3D measurement tools. I can simply say, what is the distance between that face and this face here? And it's going to give me some nice information right here on screen. And I can see that this distance between those two faces is 244 millimeters. So how do I edit this part that I brought in from the other CAD system? Well, just like we did in the part itself, is right here in the assembly, I can come in here and say, well, I need a dimension to the outside faces of this part. What is it? And you can see that right now it's at 251.81. Well, what I want to do is make that change to this part. So we saw earlier that the distance was 244. If I want to have the proper clearance on each side, then this part needs to be 242. And you'll notice I can very quickly modify that part right here in the context of the assembly to make it fit very easily for me. The other thing that I failed to show you, and I'll go ahead and do that right now, is I'm going to go back into this part, and we'll look at this part by itself for a second and just show you how, again, this is a sheet metal part. Again, for manufacturing purposes, I do need that flat pattern, so I did want to make sure that you were aware that it's not just bringing in the formed part, but it'll also flatten that out for manufacturing purposes. So let's go back out to our assembly. We've got this part now in the proper orientation, working the way that we want. The next thing that we want to do is bring in some other components, and we'll go ahead and hide the dimensions for this, just to clear up the display. So let's go to another CAD file type. Maybe this time instead of this particular option, we'll go to some other file types here, and we'll open up another component that was created inside of this other CAD application. And again, what standard do we want to utilize? We'll go ahead and open up this part as well. And very similar to what we did before, we can optimize this part to work very easily and a little bit more efficiently here inside of Solid Edge. And again, if we wanted to go through and make this an actual sheet metal featured part, we can come through and just transform this dumb solid into recognizable features, tabs, and flanges. So we'll go ahead and save this out as well. We also want to utilize this part inside of our design. So again, I can come in and insert that component as well. So we'll take this from the library and bring it in. And again, just utilizing the same types of applications we did earlier, Let's go ahead and assemble this to our existing components. And we'll line some faces up here. Now the next thing I might want to do is I might want to center this part. We have a nice application here that allows us to center these parts together. I just simply grab the outside faces of the two components that I want to center, and it'll find where that needs to be. Okay, so as we look at this particular component, we may need to make some modifications to it as well. You can see right here that we've got quite a bit of interference between the part we just brought in and our native Solid Edge component. And what I want to do is eliminate that. So right here from the assembly, what I can do is I can tell Solid Edge to make these two faces parallel. And what it'll do is it'll modify that for us automatically and change the angle to where it's not going to be bent and interfering with that part. Now we do have a little bit of slight interference still. If we want to change that, we can do that very easily just by simply creating another jog. We looked at that jog feature earlier. I just want to include the edge of the part we're interfering with, and then again utilizing that jog feature, I can go ahead and add a couple of bends and a flange to eliminate that. And essentially just put a step in the part to where that can sit on top of the other component that we're looking at and eliminate that interference. So again, I hope you can see how bringing in data from other 3D CAD systems, how you can make it usable here in this sheet metal environment. Being able to take imported geometry and convert that to very editable, workable Solid Edge files and very quickly make some changes to that. Now one other thing we can do here inside of the assembly itself, and this is very unique to Solid Edge, is as I'm looking at the assembly files, is I may need to add some additional features to the part. The lifting mechanism needs something to hold on to, and I don't have that feature yet. So what you'll notice is I'm working in the assembly, but I can make very quick changes to components. So just by switching how I want to work within the assembly, we have these options here. Do I want to do something with the part as a whole, or do I want to make some other changes to individual areas of the parts? And I can do that quickly just by simply selecting the edge. And notice right here at the assembly level I can pull off flanges to add to my design. So maybe I want to put a 50mm flange there. Maybe I also want to come in and maybe add that mounting hole. So we'll go to our hole feature, and this will allow us to come in and add a hole to that part so the lifting mechanism can get applied. So we'll make this maybe a 15mm hole. And again, I can reference edges off of that part very quickly. And place the hole right inside of the flange. So again, this is working with data being imported in from other CAD systems. It allows us again to modify it for how we need to utilize it. Now there's some other applications that we could utilize when importing in geometry, and that would be from a 2D perspective. There is a lot of 2D AutoCAD data out there, whether the company was utilizing AutoCAD as a previous CAD system, or maybe they're, again, utilizing data that was created from a customer or a vendor. And the only thing you have access to, maybe in this case, would be a 2D drawing. So I want to show you some other applications here. You'll notice here we can open up DWG and DXF files directly here inside of Solid Edge. And I may want to come in and open this up into our 2D modeling format. So in this example, we have just a very, this sheet metal bracket here. You'll notice it has some bent up material here. We've got some slots, and we also have some holes. And what Solid Edge gives us the ability to do is to very quickly create a 3D model from a static 2D drawing. And we have some nice tools that allows us to do that very easily. So again, as I access that particular tool inside of Solid Edge, it's called Create 3D. And what I want to do is I want to construct a model utilizing the existing information from my drawing. So the drawing contains not only the 2D geometry, but it also contains the manufacturing information. Where do the slots and the holes reside? What is the overall size of this part, etc. So what I can do here inside of Solid Edge is I can say I want to bring this into a 3D modeling environment, and what do I want to do? All I have to simply do is select the 2D geometry as well as the dimensional information, and I'm just going to select the 3 views that contain all that information. And as I hit finish, what Solid Edge will do for me is it will do an automatic copy and paste of that information into a modeling environment. So it'll line the views up relative to each other, and it also brings across all the manufacturing dimensional information for this part. So what can I do with this? Well, number one, I can visualize what this part is going to look like just by looking at this wireframe data. But I actually want to have a nice model of this that I can utilize inside of my 3D design. So what I'm going to do is I'm going to hide a couple of the views, and let's just, for example, look at the cross-section here on the front view. And what I'm going to do is just simply select that geometry, and then I'll turn the other views on as a reference. And utilizing Solid Edge with Synchronous Technology, I can utilize those views as a reference for the 3rd dimension. So I can take the cross-section, extend it to the depth that I need, and then utilize some of these other views for the other features. In this case, I want to generate those slots, and I just simply select the slots, and then Solid Edge knows to remove those from the original feature that I created. So I've generated all the slots on both sides very quickly. If I rotate this around to the front view and just zoom in a little bit, I may want to do the same thing with the holes that are residing on this top flange. So again, I just window select around those holes, and I'm just going to make those come through that top flange. Now I have those same exact holes on the other side. What I can do now is I can actually take those holes that I just created and just mirror them over to the other side very easily. And that'll place those onto the other side. And then just as the last feature, we have some rectangular cutouts. I can just select those 2 regions and again just remove the material through that bottom face. Now as I was going through this process, you probably noticed that the dimensions turned from an orange color to a blue color. And what that means is it just simply took the 2D information and automatically attached itself to the 3D model. Now what's nice about this is I can take that 2D information, the 2D sketches, and I don't need them anymore because Solid Edge handles all of the intelligence now directly in the model itself. So even if I delete the sketches, I still have now the 3D solid model, which contains all of the manufacturing dimensions that were automatically attached to it as it was being created. So I can also now make some other edits if I needed to. If I want to change this part, you'll notice that I have a dimension, for example, locating the width of this slot. I may want to maintain that at 1 inch. Same thing here is I've got this other dimension that's locating the holes. So I may want to come through and change its location as well, or maybe change its value, or maybe maintain that value. So I can lock that dimension to be maintained. And as I zoom out, maybe I want to make this sheet metal bracket a little bit wider. So notice as I click on the dimension, it'll allow me to adjust and make modifications to this part to whatever size I need it to be. So again, we saw modeling from scratch inside of Solid Edge with our pulley cover. We saw bringing in data from other 3D CAD applications and utilizing it and making it work for us. And then we also saw being able to take 2D data from a drawing and creating a very live, dynamic 3D model just in a matter of a couple of minutes. So with that, I'm going to go ahead and turn it back over to Barbara, and we'll turn it and open it up for some question and answer.
Thank you so much, Kevin. That was really wonderful. Thank you. We can tell you've been instructing hundreds of Solid Edge customers for years. It was really clear and helpful. I have a question. I want to know, what are the most common questions you get asked about Solid Edge ST6, for instance?
I think maybe as it relates to sheet metal in particular, you know, I guess one of the questions that are asked, you know, we saw bin tables earlier, you know, being able for Solid Edge to automatically generate bin tables to specify bin locations and things of that nature. A lot of times people will ask us, well, what else do you have in terms of manufacturing? I got this sheet metal part designed in Solid Edge. How do I get this part manufactured? Well, one of the tools that's available, and let's maybe go back to our assembly just for a second, and let's maybe look at these sheet metal parts again. Let's look at all the sheet metal parts here, and we'll do a show only as we did before. As we look at some of these sheet metal parts, you know, besides being able to specify how they're bent and what that information is, in order for the machines to laser cut the parts to bend, they have to be fed information into the machine. And oftentimes these machines will read in DXF files as an example. So one of the questions is, how do I go from this nice 3D model to a 2D representation of the part? Well, we can obviously place drawing views of the 3D model and then do a save as DXF or DWG. But one of the other options that we have inside of Solid Edge is we can take this bent sheet metal and, for example, let's maybe take let's go ahead and take this back piece. This is a pretty large piece. It's got some information. As I edit into that part, what you'll notice is we have an option here called Save as Flat. So what Save as Flat allows us to do is it'll allow us to create a DXF on the fly for manufacturing purposes. So as I save that, all I have to do is specify how I want to save this part out, and it'll generate that 2D DXF file automatically for me.
Well, that's really handy, to say the least.
Mm-hmm. Are there any other questions online, or? Barbara, are you there?
Sorry, hi. Can you hear me now?
Yes, there you go.
Can you hear me, Kevin? Okay. No,
Yes.
I think the questions, you know, I think you explained everything really well, and everybody was really happy with your demo. No question asked, and everybody stuck it till the end. So it was a really good presentation, and everybody seemed very satisfied. So I'm taking the screen back, and I'm going to wrap it up, thanking everybody from attending our Novedge webinar. And I want to also remind everybody to check out our webpage at novedge.com and to take a stroll through our aisle of products. And remember, Novedge, it is the best way to buy design software, so come visit us. For information also on our next webinar, it will be, hold on a second, the Ultimate Revit Custom Material Marathon. And if you can tell, a rendering was created in Revit simply because you recognize the brick, this webinar is definitely for you. To rewatch today's webinar or previous webinars, check out the Novedge Vimeo or YouTube channel. There's a lot to choose from in our playlist, and especially to rewatch today's webinar or to tell some of your friends or colleagues. You know, you can find it on YouTube, on Vimeo, as early as this afternoon. Thanks Thanks again for joining us and have a wonderful day. Thank you, Kevin, and to the next webinar.
Thank you.
Thank you. Bye.